Everybody, welcome back to another production ESP32 stream. My name is Kevin. Because people have asked, I'm going to start the stream by saying I am available for ESP32 consulting, help, things like that. If you need some help getting unstuck on a project or anything like that, please reach out. Let's talk about it and see if I can help you get that figured out and at what rate to use. So, happy to chat with people about their projects. So, okay, what are we doing today on the stream? Well, today on the stream, let me get the chat open up here. We're going to be porting a simple Arduino project. And so I've had people reach out, a bunch, just, talking about the difference between Arduino and Platform IO and raw IDF. And a lot of people are using Arduino and are worried about the jump from Arduino to IDF. Very scary, like crossing a Grand Canyon. And I don't think it's as scary as people think, and so I want to just show just an example. Now, these are going to be somewhat snowflakes, meaning every port will be a little bit different. However, there's a few common themes that I think this will, uncover to help you see, like, here are the main things that you're going to have to change or do in order to get your project from Arduino into IDF. Now, full disclosure, what we're going to be doing today is keeping the Arduino syntax by using the Arduino ESP32 core library provided by Espressif. So it's an abstraction that keeps the Arduino syntax that you're familiar with, but allows you to build in native IDF and use all of the native tooling, all the options. The entirety of IDF is open to you, but you get to stay in the syntax of Arduino. Very common and nice bridge to start, so you don't have to go full drop Arduino and then rewrite everything in raw IDF APIs. You can actually do both to start, and then over time, if it makes sense, start using the native IDF stuff. I want to be clear, the Arduino core library that we're going to be using from Espressif is literally just Espressif's version of a wrapper on top of their native API calls anyway. So for that matter, it's a great reference to learn about what the native IDF calls would be because they've wrapped them in that Arduino syntax. So for things like connecting to Bluetooth or Wi-Fi or reading sensors, like you can see what it's doing under the hood. And it's a nice way to kind of ease you into IDF. So it's not this, jump off a cliff type approach. So that is what we're going to be covering today. And so let's come down to this other screen here. We're going to be using this project as our starter today. So this is from Random Nerd Tutorials. They are putting out a ton of content about doing stuff on the ESP32. Most of it is in, maybe all of it. I don't know. I haven't consumed all their content, but most of it is Arduino based. They're starting to do a bunch of stuff on FreeRTOS, but it's still via the Arduino setup. And so this is a popular article, this web server using LittleFS file system. So the idea is you're going to run your ESP32. Again, as always, we're just using this little dev kit here as our playground. It's going to connect to your Wi-Fi. It's going to start a web server, and then it will accept requests to show this little web UI, which I actually have open over here. So you can see on a desktop, it's just, ESP32 LittleFS web server. So that is what we are going to start with. It's all written in Arduino, in the Arduino IDE, which we're going to show here, right here. So I've made a few changes to the project. So let's go over that. So you can see the totality of this program is 131 lines of code. So this is the thing that Arduino enthusiasts love. 131 lines of code, and I've got a web server running on an ESP32. Like, how on earth would I even start to do that in ESP IDF? And that is a great question and a valid concern. If you were to just stare at a blank editor of like, I'm in ESP IDF and VS Code, what code do I start writing to get to this end state of like showing a web UI? And I'm not going to lie to you, you're not doing it in 131 lines of code. But what we need to remember is that even though we're in this web server INO file, all Arduino is using is the Arduino core library from Espressif. It's already using that same library, and it's just packaging things in a fixed way for you. And it gives you some things that you can change. For example, I'm going to come to the tools menu. I can change CPU frequency, core debug level, flash mode, flash size. This is it. These are the settings that I can change without doing a lot of crazy gymnastics to program my ESP32. Now, if I have a bigger, more complicated project, there's 10x, 20, 50x more settings that I could control if I was using IDF natively. And so what we're going to do is show you how to get there as just a stepping stone, like as a point along the journey to go from Arduino to native IDF. So that's what we're doing. Nightcry, thanks for joining. And so let's just look at the sketch here to start. Now, what I've done, the actual example requires this BME 280, like it's meant to show you temperature and humidity. I didn't want to wire any of that up. I just want to use this raw board right here without anything else attached to it. So I've gotten rid of, not because it's hard, but just because I don't want to mess with the extra hardware setup. So I've commented those things out because we're not going to use them. And what I've done here is in the get temperature, get humidity, get pressure functions, I have just hard-coded values. This is where you would read from a sensor. And for now, I'm just, for convenience and ease of making this video, I'm just hard-coding them. And we'll focus on the rest of it, which is connecting the Wi-Fi and hosting the web server and LittlFS. And like, there's still a lot of stuff that we're porting over, but it's just not the BME 280. So, and that's it. And then you've got this processor, which is looking at turning, getting the temperature to fill out this web page. You have your typical setup and loop, which you'll see loop is empty because after you do server.begin down here, that's just running for you. It's just hosting that web server. You've defined all your endpoints here, like on, off, temperature, humidity, pressure for the web UI to call. And you'll notice up here, we're loading two files, index.html and style.css. Now, if you've ever done anything with web pages, you know that you have to have some sort of source. And the way this works is in the Arduino is you have this data folder, right? And you just put your index.html and your style.css. I grabbed both of these directly out of that tutorial, which I guess I can link in the description. And once you're in Arduino, like you have to get those source files onto your ESP32. And so the way that's done through the Arduino environment here is you've got, I think it's under tools. Oh, I'm forgetting where that is. It's not firmware updater, sketch. Oh, there is a, well, you know what? Let's just come down here. They talk about it in here. I just can't quite remember how we get access to it. Wiring circuits, create the HTML file. I do not want your free book right now. Updating, create the CSS file. Yes, yes, yes. How the code works. I swear there was a, like, how we get the files onto. Oh, here we go. Sketch, show sketch folder. Yep, we do that. Oh, Control-Shift-P. That's right. You got to use like the VS Code style menu. Okay. So in the editor here, you do Control-Shift-P. Yeah, here we go. And there's an upload LittlFS to blah, blah, blah. And so we would do that. We've specified it's in the data folder and it would upload those to our ESP32. Now we don't have really any insight into where it's putting it, how partitions work. Like Arduino abstracts a lot of that away from you. Which again is good, but also can be bad if your project is a little bit more complex. Okay, so what would we do to take a project like this that works? We've already got it running in Arduino, everything looks great, and port it to IDF. So that is what we are going to work on today. And so let's see, how do I want to do this? Playground. All right, I'm going to bring this to the foreground. I actually did this once already, but I'm going to delete all of it. So I've got this Arduino port. I'm just going to do delete permanently. Delete. That's all gone. And so this is just my, if you've watched the stream before, this production ESP32 playground, it's where I'm doing a bunch of different just research and testing and feature exploration. And I've built a couple of things into it. This repo is available. I'll also link it in the description. And so this is now no longer going to be in a valid directory. Okay, and I should probably just plus maybe make that a little bigger. Okay, perfect. So what are we looking at here? Why did our terminal disappear? There we go. Because I resized. It doesn't like that I did that. It's like a VS Code bug. There we go. Okay. All right, so I'm in my root prod ESP32 playground. And what I'm going to do, this is just, again, some syntactic sugar that I've built into this environment is NP, which stands for new project. And it's going to ask me, what's the project name? I'm going to say Arduino port. And it's going to say, great, I just created that for you. And this creates boilerplate code. Now, for any ESP30, just like any coding project, you need to have some amount of boilerplate code to start with. Like you have to have a main if this is C or C++, you know. And so that created this folder, Arduino port, and it creates the very bare minimum IDF required files to have a project, which the README is empty at this point, just says Arduino port, great. It has this CMake list, which is an IDF concept. Again, this is all happening under the hood in Arduino land. It's abstracted away from you. Most of this is all boilerplate except for the project name down here. I have this minimal build set to on, which we're going to actually, I covered this in a previous stream. This tells the IDF build system only build the explicit items that I know I need and I'm including. If you're doing a port, I would recommend not setting that. Like to get started, to make the transition easier, you should turn that off and just say, build everything and find it for me. And then later on, you can worry about finding what the explicit dependencies are and including them. This is kind of a cheat code shortcut. When you're doing the initial port, I would not set minimum build on. All it does is save you a little bit of build time in the case of a full project. But when you're starting a port, that's not something you're worried about. You're worried about getting it working in the new environment. So we're going to make that change. And then in the main folder here, we've got another CMake list, which just says, hey, I'm going to build this main.cpp file, which is right here. And I've got this hello Arduino port. If I take this and I turn on, did that work? Did it? I'm not getting a light on this thing. I don't know that that's working at all. IDF.py flash monitor. Is it going to find anything? No serial ports found. It's very interesting. Sure enough, I do not see a port there. Let me try that again. Interesting. Let me try a different port altogether. Oh, I'm pushing the wrong button. Jeez. Ta-da! It helps if I've got a USB hub here. Helps if you turn the right thing on. Okay, now let's try an IDF.py flash monitor. It still says no port found. Is that true? No, it's definitely found. So what's the... Or busy. Okay, I do have the Arduino IDE open. And it is running. So I need to close the serial monitor in the Arduino IDE and come back and flash monitor. Third time's a charm, maybe? There we go. Perfect. Okay. All right, so you can see here it's building, flashing, all that good stuff. And from, again, our base example, it just says hello Arduino port. So we know that our environment's working and we're building and all those good things. So, and again, animatronics sounds great. No worries. I know you got to run. Check it out later, and if you have any questions, just let me know. Okay, so I cover this in many other streams of how I set up this environment. It's all using VS Code and dev containers to be able to just build with the native IDF. And really what you just saw me do, idf.py flash monitor is all it takes. Like I know you're used to clicking the button in the Arduino IDE of like build and upload. That's what I just did. idf.py flash monitor. If you know like 3 or 4 idf.py command line tool like arguments, that's everything you need to get going. They also have an extension that allows you to like click build and click flash and upload. I personally don't use that, but you can. That's native IDF. So that is it. Let's go ahead and clear this. And now let's start to do our port. Okay, so now we've got a working main.cbp, but now I want to take that Arduino project that we were just playing with and port it over. So the first thing I'm going to do just to get started is I'm going to come back over to here and I'm just going to grab exactly line for line the entire sketch. Okay, and I'm going to replace my code completely empty with that exact same sketch. Okay. I've got auto format on, so that's why it changed the loop there. But this is the exact same code that was working in our Arduino sketch. And now we are in the IDF environment. And so the next command that we're going to do and learn is idf.py build. Like I know we all like our buttons, but really we can just type build and flash and monitor from the command line. It's really not that hard. And so I'm going to try to build this. Now this is obviously, that would be amazing. It's not going to work. So I'm going to hit build and it's going to be like, I don't know what async TCP is. I don't know what little fs is. Like, I don't know a bunch of things. It's going to stop on the first one, which is the very top one. And so this is the first major step after copying code over to port your Arduino project to ESP32. And that is we need to install some dependencies. And so if we come back to our Arduino, you'll notice I have this async TCP library installed, and I have this async web server. Let's get rid of the async, the TC part of this, and do another search. Let's do web server. It's not coming up. How do I just show installed? Here we go. Okay. You can see I've got Arduino JSON. That's not for this project, but I've got this async TCP library installed. I've got ESP async web server library installed. Wi-Fi manager, that's not for this project. But these are the two. Async TCP and ESP async web server are the two libraries I have installed that allow this project to work. So, lucky for us, Espressif has a very similar thing to the Arduino library manager, and it's called the ESP component registry. This is going to be your best friend when you're just getting started with ports, because you can come into here and almost just like you can add them, it's slightly more high friction than Arduino, but not by much, and I'll show you that. And so we need to install a couple of things. The very first one that we're not going to see in Arduino is this one right here, this Espressif Arduino ESP32. This is the exact same thing that Arduino IDE is using that we also need to include in our project, which is that wrapper I was talking about earlier that Espressif has written that gives you the Arduino syntax, but wraps all of their low-level IDF APIs. And so this is for any port from Arduino over to ESP IDF to get started, unless you want to start a rewrite from IDF scratch native, you're going to need this library. And the way we do that is you can see right here, to add this component to your project, run idf.py add dependency. There's a little copy button here, so we're going to do that. And we're just going to come down to our command line. Oh, sorry, wrong command line. We need to be in VS Code. Okay, let's clear this. And I'm going to just paste that. idf.py add dependency, Espressif Arduino. It's going to do some things, and it's going to say, hey, I did it. Now, what that did is it's going to create, I need this to update. There we go, idf component.yaml. And it creates this little YAML file, and it shows right here, here's one of your dependencies. We just added the Arduino ESP32. Okay, great. So that is the first dependency you're going to need. Now, the other ones we're going to need, we were just looking at them, is the ESP async web server and the async TCP. So we're going to come down to our component registry, and we're going to do async TCP and do a search. And it's going to say it didn't find anything because I don't know how to spell async. Okay, you can see I've got ESP32 async TCP. This is from the same people that have created the Arduino one. Now, I don't want to get anybody's hopes up. You're not going to find a one-to-one. Every Arduino library is going to have an ESP component registry equivalent. There are going to be a lot of them, and especially the ones that are well-maintained and effective and good, they are going to have an ESP component registry equivalent. If not, and I'm not going to cover it in this stream, it's a topic for a different stream, a lot of times you can just copy the raw Arduino code, add it as a component manually to your project, and make a few tweaks and make it work. So even if it's not in the component registry, it's still not, that's not a hard stop. Oh, I can't port my project. It may be easier than you think. Okay, so we're going to grab this, copy to clipboard, and we're going to get back into Visual Studio Code, and we're going to add this as a dependency, and you'll see that it's just going to add it to this file as well. It should. I don't know why it's having a hard time updating. There it goes. Okay, let's come back down here, and the last one that we need is async web server. ESP async web server. Again, it's by that same, you can tell by the logo. So let's grab that and add it. Okay, and now you'll see all three of those have been added to our component.yaml. And great. So now that we've got our dependencies, now let's try to build and see what happens. Okay, so I'm going to do idf.py build. Okay, it's still saying no such file or directory. And this is an ESP component thing because what we've done is we've added all of these, but it doesn't know that it needs to pull them in. And so what I found is, let me just remove the build folder. I think that may be all I need to do here. Delete permanently. And then let's try the build one more time. Because it should try to solve, yeah, right here. Dependencies lock doesn't exist, solving dependencies. So what it's going to do is say, hey, I have all these dependencies. I need to go out and pull them down in. Okay, and so what that does is it creates this managed components folder. Okay. If you're familiar with IDF, there's a components folder where you can write your own components. With the component registry, there's this managed components folder. And if I open this, you'll see I have a whole bunch of things now. And this is all the component resolution happening. So you can see I've got this async TCP, async web server. You don't have to worry about any of this code, although you're more than welcome to open it up and come down in here and actually look at the code. But for our purposes, we're just going to assume all of the dependencies that we need have now been installed. We don't have to do anything except maintain this YAML file. Okay, so that those same library dependencies that we had in our Arduino project, we now have in our native IDF project. All right, but unfortunately, the build still failed. Why? And it's saying, hey, ESP32 Arduino requires config FreeRTOS Hertz equals 1000. Currently, it's set to 100. And so if I look at this, I actually don't think this will let me come in here, but idf.py menu config. This is one of our new commands that we're learning in the native IDF. And this is how, I showed that menu in the Arduino where I had like a dozen different settings that I can change. idf.py menu config lets you change everything in IDF, like full control, hundreds of settings for you to play with. And now, again, it's saying, hey, I don't like this. I do think this is a bug, and this makes it very scary and hard for people, where it's saying, hey, I can't, you need to have this certain config setting. Well, the way you set config settings in IDF is through menu config, but it's chicken and egg. I can't launch this. And so we're going to introduce a new concept, which I highly recommend for any of your projects, which is you can seed the config with certain values like this config FreeRTOS setting. And the way we do that is in our top level CMake lists. I know it seems like it's getting scary. It's really not. Like it's new. Don't let it scare you. Right up here in between in our CMake, we're going to set this right here. This SDK config devals. This is just boilerplate, copy and paste. There's nothing else to know about it here. That says, hey, look for this SDK config.defaults file, and whatever's in it, apply it to my configuration. And then what we do is just at the top level here, we do a new file. We name it SDK config.defaults. And we can put any baseline settings in here. And so I'm just going to copy this and paste it and say, hey, whenever you create a config, start with this and override the default. Now, new command, idf.py, full clean. It's going to say, hey, take the whole build folder, and it's going to say it's refusing to automatically delete, blah, blah, blah. So we can just delete it manually. But until we get a successful build, it can get into a weird state. So we're just going to delete permanently. Yes. Now we're going to do idf.py build. We should not get the same config FreeRTOS Hertz error at this point. I don't think the build's going to succeed. I can't remember if it will at this point or not. Okay, great. It did not. Okay, scary output time, but not really. You just got to know how to read it. It compiled fine. You'll see that up here. What it failed doing was linking. Let's roll up so you can see that. Linking executable. For every time you build firmware, it does two main steps. It compiles all of your source code. Once it has those objects compiled, it links them into your final executable. We are failing at that second step, which is the link step. Down here at the very bottom, it's being super helpful, and it's saying you have an undefined reference to this thing called app_main, which is not something we have in here. We have a setup and loop, because that's our Arduino syntax. So what's it talking about app main? Well, in a raw IDF project, it's looking for an app_main because that's what it wants to launch out of the bootloader. So let's now come in to idf.py menu config. Now it opens because that we solved that config FreeRTOS thing. And now you can see here, there's this Arduino configuration. We only have this because we're using that Arduino ESP32 library. And as you can see here, where's that one setting that we changed? That was 1,000. That should be, that was 100. Huh. Oh, it's in a different area. Okay. All right, a whole bunch of settings. You don't have to worry a lot about this, but you can see right here, there's this setting called Auto Start Arduino Setup and Loop on Boot. And if we hit the question mark on that, it will tell you enabling this option will implement app main and start Arduino. All you need to implement in your main.cpp is setup and loop and include arduino.h. So this is, again, helping you with that bridge saying raw IDF prefers app main, but if you select this option, we'll create app main for you and basically call setup and loop. And so that seems like a great way to get started. So we're going to go ahead and say, yes, please do that. And now, if you're looking to do multiple projects, you can see the name of this config is Auto Start Arduino. So what I'm going to do is I'm going to take that, I'm going to copy it. I've set that. I'm going to exit out of here and say, yes, save my configuration. But I'm also going to come in here and say, hey, config underscore that thing is yes. Like I definitely want that to happen. Okay. Great. So now we have, let's try and build again. now that we've got that setting, and see what it tells us. It's going to go through and try and resolve those dependencies. And dang it. We're getting a failure again. This one, when I went through it the first time, is a little weird. I'm not going to lie. You're getting this undefined reference to wrap ESP log write V. I did a little bit of research on this. This is kind of an interesting one with the Arduino core stuff, but again, it's just one of those, once you've figured it out, it's done. There's nothing else to it. And that is, we need another configuration setting, which I'm going to add here now because I just copied and pasted it. Config diag use external log wrap. And you're like, oh my goodness, how would I have ever come up with that? I didn't know either. I Googled it. It took me 2 minutes and I found the answer. But let's come in here and look at it. Diag use external. You see I have it turned to, it defaults to no, but let's come in here and look at it. Diagnostic component wraps the ESP log write and write V APIs using wrap GCC option. There can be a scenario where another component also wants to wrap this, blah, blah, blah. This I just found in forums. To be honest, I don't understand why this fixes that compiler warning, and honestly it feels like a bug, but I'm going to go ahead and enable it. I've also added it to my defaults so that if I do a fresh build, it'll automatically be set and I don't have to change it in here every time. So let's go ahead and save that. And I hope you're seeing here, like, you're going to run into these things as you're porting your project. Each one is definitely solvable, and I think what happens is people see these walls of text and get scared and are like, nope, it's too hard. I promise it's not too hard. Like, somebody else has already solved the problem. You just have to find it and do the same thing. Okay. Let's go build again, see where that gets us. And I think we're about at the point where we should be at full build. Let's see. Hey, we built. And everything is there. Now, in the interest of saving time, at this point you can flash and it's not going to work. Nope, let's do it. Like, hey, I got it. It's building now. Let me do idf.py flash monitor. Again, you can do idf.py flash and then idf.py monitor. This is just a combination where it's going to do the flash first. Flash will build it if it's out of date, upload it, and then monitor says I'm going to monitor it. So let's go ahead and hit that and see what happens. All right. Oh, bummer. We got an error and like, what's happening? And now we're getting more errors. What's happening? So I'm going to exit out of that, and then let's just kind of look at this for a second and think about what's going on. Detected size larger than size in binary image. Oh, okay. Darn it. That's just a warning. We can ignore that. What that's saying is, by default, IDF says you're probably using a 2 megabyte flash chip. In our case, this little dev board that we have is 8. And so it's saying, hey, there's a mismatch there. Doesn't matter. It still runs. It's just letting you know. We'll fix that in a second. With some more SDK config default magic. But now it's saying failed to initialize little fs. And then this is saying ESP little fs partition spiffs could not be found. This is more magic that Arduino is, abstracting away from you so that you don't have to deal with. But you have to think about this little ESP32 dev board as a computer with a hard drive. And just as you have partitions on your hard drive where it's like, this is where the OS goes and data goes, and maybe there's a recovery partition. The exact same thing is true of the ESP32, except if you're used to Arduino land, all that stuff is hidden from you. The most you'll ever see it is if you come to here into tools, This is the same thing. This flash size, that's that same error we were getting earlier. Arduino defaults it to 4, so you would change it here. You've got this partition scheme, and then they give you, it's seemingly a lot. And I guess you can do custom. This didn't used to be there. And there used to only be like 4 options. But this is that same thing I was just talking about. This is saying, this is how we're going to lay out the hard drive or storage on the ESP32. And you can say the default is 4 megabyte with spiffs, which means you have 1.2 megabyte for an app and 1.5 megabyte for spiffs, which is a fancy term for like storage hard drive on your ESP32. It's actually a misnomer in this case because we're using little fs, different file system than spiffs, but it all ends up working. And you can select different versions of these of like no OTA or with OTA. And in the case of OTA, you have to have enough room for both apps and things like that. So this is how Arduino partitions your ESP32. In raw IDF, the concept that we need to understand here is there's a partitions. Let's actually show it here. Let's come back into idf.py, menu config. We can do a search for partition. Let's see. There we go. We've got partition table. So let's navigate to it. I'm doing a search, which maybe I'm getting ahead of you on. So let's come just to the raw menu here. As it loads up. Not sure why that's stuck. There we go. I don't know why it was getting angry with me. Okay, you've got on your main menu here, you've got partition table. We come in here. You can see by default it says single factory app, no OTA, and you can come in here and you can select single factory app, large, no OTA, factory app, two OTA definitions, 2 large OTA, or custom partition table, which in our case, we're going to do a custom partition table. I encourage everybody to figure out partitions. It's not hard. It's just a little CSV file that says, here's how I want the memory laid out on my ESP32. So we are going to do that, but we're not going to do it through menu config for the sake of time. Just know that this is a major part of porting over to IDF, is you're going to have to resolve this idea of partitions. And you can either do it through menu config like I just showed. I highly recommend going the custom route. And so I'm going to drop in a bunch of code. Don't let it scare you. Back into our SDK config defaults right here. Let's come down here and we're going to go through each of these one at a time. Don't worry. Okay. I set this to 4 meg, but I think they said the chip was 8 meg. So let's change that. This is going to resolve that warning we were seeing, which is saying, hey, the flash size on this board is actually 8 megabytes. And then the rest of this is, I'm going to say, give me a custom partition table. Again, you could do all this through menu config. I'm just codifying it here in the defaults file. And I'm going to say, use this file called partitions.csv. And that's where I want you to get your partition information. That just lives in the root of the project. So I'm going to do a new file here, partitions.csv. And let me drop in what that looks like. For simplicity, I kept the naming of this. I'll go over that in a second. So NVS, this is a key storage value. Again, Arduino's using all this under the hood. You just don't get to see it. I'm using an OTA layout, which means I can actually OTA this device. So it creates 2 app partitions, both 1.7 megs in size. And then what this example is looking for is this spiffs partition. It's 512 kilobyte partition or hard drive space on your ESP32 where you can put files like index.html and style.css. All right, and I've said that this is little fs, it's a data partition, and all that. So I'm going to save that. I'm going to save my defaults. And the reason I like to use this is because I'm going to do an idf.py full clean. This is going to clean my entire build directory. And now when I build again, I don't have to reset those settings in menu config. Okay, so idf.py build. Okay, and again, this is because our code, if you remember, was saying, hey, I don't know about this partition that you're looking for called spiffs. So what we've just done is said, hey, now you have a spiffs partition to load at boot. Okay, so the build succeeded. And now what we're going to do is we're going to run it again, see what happens. Flash monitor. Okay, it's going to boot up. It's going to connect to Wi-Fi. You can see it says connecting to Wi-Fi. But we got past the point that we got before, which I believe was way up here. Our yellow message of flash size mismatch is now gone. And I think we should see a... well, it says calling at main. I guess we don't see a little FS positive message if it works. So anyway, we didn't get the same error. And now we're getting this task watchdog got triggered. I did get connected and I did get an IP address and everything's running, but I keep getting this watchdog timeout. Now, this is one that you just kind of have to know what's going on here a little bit behind the scenes, but very easy to fix, which is when you're running your program in raw IDF, you've got FreeRTOS running, it's running a thread, and in the case of the Arduino code, again, they're abstracting this away from you. Setup runs as a function, and then loop runs as a function as well. But with the Arduino abstraction on it, I'm assuming they're doing some sort of sleep, because what we have currently in our code is we've got a setup that does everything, and then loop is empty, but IDF's calling loop as fast as it possibly can, and it's not yielding control to anything. So what's happening is it's stuck in an infinite loop by design, but other threads need to run. And in the case of the Arduino IDE, I believe that they're going to do what we're about to do just outside of the loop function so that it handles it for you. But what we need to do in here is when you have any sort of an infinite loop in IDF, is we need a delay. Okay, and I believe, I don't even remember the Arduino syntax, just delay. Yeah, okay, so let's do while one delay. So on this main loop, since it's not really doing anything, and in a real project, you wouldn't have this problem because your loop would do something. In this case, since it doesn't, we just need to yield control so that other threads can run, and we won't. Nothing is wrong here. You're getting this backtrace, and it's scary. It's still running. It's just it's telling you, hey, you're doing something a little off. Okay, so if we add this delay, we should be just fine, and we shouldn't see that anymore. So let's give that a shot. Okay, now remember, I just want to point out, I copied this code straight from the Arduino IDE that was fully functioning. I have changed nothing other than this. So our raw code from our Arduino project is exactly the same. I just added this. And so now what we'll see here is we shouldn't get that, watchdog error anymore saying, hey, you're not yielding control to the processor correctly. Now we are. And again, in a normal project, you'd probably have something in your loop that you're doing and checking on every once in a while. So you wouldn't have this problem anyway. And so anyway, that's how we fix it in this example. And so now it says, hey, you can just connect to this IP address and everything should work. So let's try that and see what happens. It worked, and it's not supposed to work because I was doing this before. If you're following along at home, this would not work for you. And the reason it would not work for you is because one of the things we haven't done, if you remember, early on in the video, we had to supply an index.html file and a style.css file. And we used the Arduino IDE to upload those files to our ESP32. And we haven't done that in this case. The reason it's working for me, and I should have been more prepared, is that I did this previously and the files are still on here because I have not completely erased the chip. So it's actually finding the files even though they're not there, but they are there. In your case, like I said, if you're following along at home, those files would not be there and it would not load and you'd get errors in here saying like, I don't know, when it tries to call this up here, this would fail because it's like, I don't know where index.html are. And so in Arduino land, we had to create a data folder and put those files. And you notice we haven't done that here yet. And so let's, I'm gonna do that off camera, as it were. Let me just find those files, and you'll see them come in here in just a minute. Let's do home. Arduino, we're getting there. A web server. Data, I'm going to copy that and I'm going to paste it into here. Okay, so yeah, there we go. All right, so now you can see all I did was copy it. That was the same folder. I've made no changes. Now you can see I've got an index.html and style.css. How do I get those onto my ESP32? In the Arduino IDE, we use the menu. In IDF Native, we do it slightly differently, and it's directly through our CMake, and I will just copy and paste it in. Again, it's boilerplate code. In our CMake list at the main level, where we register our component, we're going to add this line, little fs create partition image. Spiffs is the name of it. We're going to say, where do we want to get the files for this? And that's just the data folder, .data. So I've got index and style. And I'm going to say flash in project. This is just a magic line that says take the files that are in this folder and store them on this data partition on the ESP32, which is where our code is going to expect to pick it up. Now, to make sure that this is working, let's make a change to index. And instead of calling this the ESP32 little fs web server, we're going to call it the production ESP32 web server. Okay, so just a simple change. And then what we're going to do is exit out of here, and we're going to do idf.py flash monitor. And what it should do as part of this is it's going to take those, it's going to write them onto the partition, and those are the files that it will serve. So you can make changes, and then every time you rebuild in Flash, it will update those. Okay, we're back to, hey, connect to me. So let's come down here. I'm going to hit F5 and get the exact same thing. It looks like it. Did not get a change there. Am I doing the right? I connected to the right network, first of all. Well, we did make that change. We saved it. It is .3.214, right? I copied that directly, .3.214. 3.214. Maybe I need a shift F5. Let's grab a whole new tab here. Not sure why I would not be seeing the updates. Oh, let's come back up. Am I? Yeah. I'm up in the head. I'm not actually, I didn't actually change this. Okay, so it helps if you know something about web development. If I do a view source on this, no, that's not, I would have expected that to have been changed. Okay, so maybe not. What are we missing? All right, now let's debug. First of all, let's change the header to is this working? Oh, I didn't save this file. I'm an idiot. Look at that. See that little dot? I didn't save it. Save. Jeez, attention to detail. All right. Now it will build and add those files and upload them to the device. Yeah, it's funny. These computer things only do what you tell them to. Okay. I'll wait for that to build. And flash. And then it'll go into monitor mode. And then, assuming this works, which I'm now much more confident it will. Okay, let's update here. Hey, look at that. I got production ESP32 web server up here in the head, which is where I originally changed it, and I got is this working here. So great. We have at this point successfully taken the Arduino project and ported it to raw IDF. Now, again, I know along the way it's like, oh my goodness, those seem like really complex things. Again, it's most of it is just boilerplate that once you realize what it is, it's very simple. And the great part about this is every single concept so far, components, partitions, menu config, these are easing you into what is day in, day out IDF. And it's a way to do that without a lot of, without going full raw API IDF. Because again, remember, we still, main.cbp, this is still all of our Arduino code. We're including async TCP and little FS and Wi-Fi and wire. None of these things exist natively in IDF. They're all just wrappers that Espressif has written. And so, the component registry, all of these are the concepts that just with a little bit of effort, they get you into IDF. And now, like I said, now you have IDF.py menu config. You have every single setting available that you don't have to do weird gymnastics and folder searching in Arduino to change some setting. Like you have it natively. The other really cool thing here is that you have access to the raw ESP API. So you don't have to, this isn't just now I'm writing Arduino in IDF and I have to stick with Arduino. Now you can start to write new code with the raw APIs or continue to do Arduino, whichever you prefer. But let's just do a quick example of that before we end the stream. Let's come down here and say, like, how do we get... oh, you know what? Here's a super simple one. Let's come back up here. Nope, let's come back down here. Okay, we've got on and off. Let's see how trivial it would be to add a restart button that'll just reboot our ESP32. Now, the API for that is just ESP_restart. That's a raw ESP IDF API that we can call. So let's come over here and look at our index.html and see how the buttons work. Button 2. All right, let's just add a button 3 and see what happens. See how fast we can do this. We're going to call this, instead of off, we're going to call it restart. Button 2. I don't know. Let's just button. And let's call it. I have no idea what the styling of this is going to look like, but hopefully it gets the point across. So when we call restart, and then certainly there's got to be a way that we can... how is it knowing... Oh, it's just calling restart. Yeah, great. Okay, perfect. I think that should be all we need. I don't know that it's going to look pretty, but that won't matter. And then back in our main.cpp, we need to add a handler for it. So I'm just going to copy the on handler here. And say, if we call restart, we're going to say restarting ESP32. Okay, now look, the IntelliSense is trying to help us out here. And I'm going to go ahead and let it finish that thought. In Arduino land, you would call ESP.restart. This is the Arduino wrapper API, but that's not the raw IDF call. The raw IDF call is ESP_restart. Okay, so now I'm starting to mix native IDF code with my Arduino code. And let's put a delay in here so that we can actually see You know, delay is another great example. We have delay 100, but I don't know if this is going to work because I don't know if it properly brings it in. But if I go to definition on this, yeah, this is not the wrapper part. Okay, so this is not the native IDF way to do a delay, although I do like the abstraction. But it's actually the task delay. We use like the raw free RTOS calls. So I'm going to add that in here and say, put a 1 second delay in. This is what delay looks like under the hood. It's what it's, even the Arduino code, this is what's getting called underneath, or some other native US micro sleep function that's provided by the IDF API. Okay, so now that I've started to mix IDF code with Arduino code, I'm going to try and build and see what happens. I'm not sure if this will succeed. It did. So obviously through one of these other header files, it's included the header files that allow me to call those native functions. Otherwise, you would have to look up, hey, ESP restart. Let's just look at that really quick. You can see I'm way down in ESP system. Like there's a header file that I would have to include if one of the other header files didn't include it for me. So that all worked. Let's just flash monitor and see what happens. See what it looks like. Okay, it's booted back up. It's connecting to Wi-Fi. It's got its IP address. I'm going to leave this here. Let's open that up a bit. Let's come down here. Now I'm going to refresh and see what it looks like. Hey, actually, I guess the button, its space is fine. It's just the color. So now I've got on, off, and restart. Restart's calling our native IDF code. So I'm going to hit that. Then I'm going to come back up here. And you can see already I got things scrolling because what happened? Way up here, I got my message, restarting ESP32. It waited for a second, and then it restarted. So that's now booted back up, and now I could reload. That's just a super trivial example. But the thing I'm trying to illustrate there is now I've already started, since successfully porting my Arduino project over to IDF, I've started mixing in native IDF API code, and I can do that seamlessly. Again, you may need to add some header files that are the native IDF header files, but there's nothing preventing you at this point from creating all new code using raw IDF APIs, or if you want to continue using your Arduino syntax. So that is going to do it for the stream today. Hopefully that helped kind of explain a little bit about how you would go about porting a project from Arduino to IDF. Again, all of these are going to be slightly different and unique, but the general concepts are the same to get you to IDF. There's kind of a pattern to follow there. And while it may seem scary, it's really not that bad. I've done a few of these, and honestly, if you get stuck and you're really trying to port your project from Arduino to IDF native and something, you've found a blocker, send me an email, reach out to me on LinkedIn, other social, and ask me about it. It may be something that I can unlock you on very quickly to kind of keep pushing you forward. I'd like to push people out of Arduino, especially in product scenarios. Again, for hobby stuff, I don't really care. But this is the production ESP32 stream. For production deployments of the ESP32, we should really be using a more mature tool set that allows you to have all the options so that you can effectively do that. And so that's going to do it. Again, reach out if you have any questions. I appreciate everybody watching. And